This is a recording of data analysis project on behalf of Aramide Kehinde and Huy Tran. First of all, giving credit where credit is due, we used a data set from the Million Song data set, which is a project of 1 million songs from an application and data on all the users that listen to the song. Looking here at our Jupyter notebook, the data sets that we used well, all of the analysis was done using the Google Cloud platform. We used two data sets from the Million Song data sets. The first is a subset of 10,000 songs out of the 1 million, and the second is a repository of about 450 million users who listen to any of those 1,000 songs. We will see the schema of those data sets in a minute. This data is analyzed in the Google Cloud platform, and our goal was to do three things. We wanted to complete data analysis that would enable an application that can do three things. One, recommend songs by displaying the top 10 trending songs at a given point in time. This is for the cold start, and it's a very simple recommendation method. Second is use user-to-user collaborative filtering and KNN to recommend songs to a user based on similar users. The third is to use clustering and KNN to recommend songs to a user given the current song they are listening to. We'll detail that further down. Moving forward along, the first thing we do is load data from Google BigQuery into this Jupyter notebook that is on the cloud. And this is a sample schema of the user's data set. It shows user's ID, credential, song ID, and play counts. This represents the number of times each user listens to each song. And there is about, as you can see, 772,000 of these records. Once we take that song, the first thing we do to establish the basic recommender, recommending the top 10 songs that are trending now, is first of all calculate the number of users who listen to each song in the 10,000 song data set. And here's a sample of that. We then establish a threshold of a threshold so that the popularity model only listens to songs that are past a certain threshold in terms of the number of users that listen to it. In addition to that, once we identify songs that are within that threshold, we also calculated the average number of times each song was listened to. Then we went on and created a blended data frame that blends the number of users that listen to each song and the average number of time each song were listened to. It's important to know the difference. Number of users counts unique users. Average play count counts every single time the song is listened to. So if one user listens to a song 5 times, this metric counts for that. Once we have that data frame, we then create a function that created a weighted score. This weighted score incorporates both the number of unique users that listens to the song and the average amount of times the song is listened to. And as you can see, sometimes you can have songs that have less unique users listening to it, however, higher average play count, so that song gets a higher weighted score. We sort this data frame in descending order, as you can see, and then select the top 10. These are the song IDs that represent songs that are trending now, quote unquote. We select the song IDs from that data frame up top, and now we pull in from BigQuery the songs data set. This is the schema of about 33 to 35 features that are in the songs data set. We only care about 4 of those features that you would typically show to the user on an application like Spotify or iTunes. You see the song title, the artist name, and the album name, and plus some nice art as you would see on an app, but this is not an app. And then we show the top 10 songs that are trending now. So that's the first analysis. The second analysis is then using collaborative filtering with KNN, and we want to use user-to-user filtering to recommend songs based on similar users. Okay. First of all, we do some processing. To highlight the processing at a high level, we remove fields that are more like metadata and fields that don't really influence whether or not you listen to a song, like song loudness or Tatum's confidence. That's more metadata. Another thing we do is we find values that are NA and we replace them with the mean where possible. We also drop fields like the year where there's a poor distribution of those values. And also another thing we did for pre-processing was change the genre field. The raw data set had 458 unique genres. We wanted a good amount of examples for each genre, so we mapped that to high-level genres. First using an Excel spreadsheet where's the Excel spreadsheet? Here we go. Where we mapped the 458 to 22 high-level genres. And then we use a function to map this Excel spreadsheet so that we get in total 22 high-level genres. And when we visualize that on a bar plot, we have the new field called song genre within the data frame, and we're visualizing that. We have 22 bar counts, 22 genres, and rock music is looking like the top one. Okay, we also do some scatter plots just to find some collinearity in the data. You know, some things we learned so far is, for example, here, artist hotness is positively correlated with song familiarity, right? So if you're a popular artist, it's more likely that your song will be known, which makes sense. Okay, going into KNN now. The first thing we do is create our user-to-user matrix. We simply did a pivot table. Each row on this pivot table represents a user and the number of times they listen to each song. These columns are songs. We do not have ratings in this data set, so we had to use play counts as was seen earlier. We create a matrix out of that and then test KNN just to see if we pull out a random query index from that user to item matrix, what are the songs that what are the similar users we would recommend, and we're doing K of 5 here. So this test works. Then we turn that into a function. It's a 3-level function that's using 3 functions. The first thing we do is, first of all, given the ID that we enter in to the function, get the k nearest neighbors. After we get the k nearest neighbors, find the top listened to songs from each of the 5 nearest neighbors, or the k nearest neighbors. And then lastly, display the song data for the songs we're recommending based on the k nearest neighbors. And as you can see here, here's a test of this function, display data, that is calling the 2 previous functions. And the resulting recommendation is these 2 songs. We saw that sometimes we got 5 songs recommended or just 1 song recommended based on the k nearest users, because the k nearest users could be listening to the same songs. Okay, moving on is analysis 3. Analysis 3 then uses clustering with k-means, first to cluster the song data, and then it allows for a part of the application experience that would recommend songs to a user based on the current song he or she is listening to. And the point here is, first of all, we set up clusters for each of the songs, then we recommend a song to a user that is within the same cluster, and we use KNN again to do that. So first of all, we do some pre-processing. First, use get dummies to turn our genre field into a Boolean. We drop some categorical values because we're going to do grid search. We also create a matrix, a normalized matrix, using min-max scalar over here that creates a matrix of all the songs. Okay. Then we run grid search, and this again is to optimize and to reduce dimensionality in the set of songs matrices. Using the results of grid search, we then run the k-means algorithm, and we are looking for 4 clusters. Looking at the results of a k-means algorithm with grid search, we find we get some clusters, we visualize that, and there is a lot of noise in the clustering. So we want to try this again. We then use, instead of grid search, PCA to reduce the number of dimensions in this data set. So here we are calling the scikit-learn PCA API on the matrix of songs, and the resulting data set we ensured explained at least 95% of the variance in the songs data. We try the k-means algorithm again, looking for 4 clusters again, and this time we get to these clusters, 4 neatly arranged clusters here. The centers here are admittedly off center. In this visual, in the previous version of this, the centers were right in the center of each cluster. This is just a result of a misclick. So you will see the picture of the right visual in the report. After getting that, we now have clusters for each song, 4 clusters for 10,000 songs, which is arguably small, but this was a test for us. Then we wanted to now use the clustering results to recommend songs based on the current song the user is listening to. First, we will find the cluster of a given song, and then second, we will use KNN to recommend a song similar to the given song that is in the same cluster as that song. So here again, we have multiple functions. The first is it's going to allow you to enter the song ID. So this is pretending the user has hit a specific song and is now listening to it. Now, given that song ID, we find that index, this index of that song in the song's data set. Now that we find the index of that song in the song's data set, we use that to run a k-means clustering function that first of all finds the cluster of a given song using its index, as you can see. Then it finds the indices of all songs that are in the same cluster of a given song. So we're essentially indexing into the cluster's results and finding the indices that equal the cluster of the given song. Third, we create an array of given song for comparison in KNN, which we'll talk about later. And then we also create an array of songs in the same cluster. This next function here is using KNN, and here we're not just calling the API, we actually wrote a manual KNN function to recommend the K closest neighbors within the same cluster to the given song. And our distance metric here is Euclidean distance, as you can see. After getting the K songs, we find their indices of the K songs, and then we recommend songs by, we find the data of those K songs from the songs data set. So this is the function. This is a test of the function. It's calling song recommendation 2, that's the variable, and we're testing this, calling this function recommend K songs over here, which refers to the previous functions. We give it the song ID, we give it the song data set, we give it, and this is a data frame, we give it the matrix of PCA treated songs, and we give it the number of K songs we want to recommend. So giving that, these are our results. These 10 songs, our K is 10 over here, these 10 songs are songs that are within the same cluster of a given song the user is listening to and are also the closest to that song within that cluster. Okay, thank you very much. This has been a recording. Please refer to this recording for an entirety of all the results from our analysis. We found that while saving this Jupyter notebook, some of our visuals and some of our results didn't show up because of the large amount of data that we are working with. So this recording represents the entirety of our work. Thank you.